Okay, so today we're going to talk about mid-segment, and for this video, we are going to take some notes to start. So, first things to know about mid-segment is it deals with midpoints of triangles. Mid-segment, midpoints of triangles. Now, I taught you, when I taught you this before, Nevaeh, I taught you to look for the hidden parallelograms. And when you look for the hidden parallelograms, they're a lot easier to figure out how to do it. So for example, if I have a triangle like this, and I find the midpoints of each side of the triangle, then what I'll be able to do is I can connect, if I just connect these two sides, I can see my hidden parallelogram. And so if this is 5, I know that this has to be 5. Because in parallelograms, we just did on the front page, opposite sides are equal. And if mid-segment, yes, ma'am. That's it. That's all the notes. And then because mid-segment means midpoints of triangles, if this is 5, this also has to be 5. And so I'm going to get another piece of paper and I'm going to draw the triangle bigger just so you can see what I'm talking about. Here's our midpoints. Okay. Here's my hidden parallelogram. All I'm saying is that if this is 5, this has to be 5 because opposite sides of a parallelogram are congruent. If this is a midpoint and mid-segments deal with midpoints, this also has to be 5. Likewise, if this value is 6, because this is a parallelogram, I know this side has to be 6. If this is 6, I know this is a midpoint because mid-segments are midpoints. So I know that this piece also has to be 6. If I connect this one, and let's say I know that side is 7, because this is 7, here's a hidden parallelogram right here. This has to be 7. Because this is 7 and this is a midpoint, this has to be 7. So my technique that I highly recommend you do anytime you have a mid-segment problem is right away, before you try to solve or look for what they're asking you specifically, it's best practice if you just go ahead and do the whole triangle. Because then, if these had letters on it, and they ask you, for example, for AC, well, you've already done the work. You know this is AC. I have 7 plus 7, which is 14. If they ask you for something like what's dB, well, you already figured out what dB is. dB equals 6.
But if they only give you the number at the bottom.
Yeah, we're going to do examples. So you might not be able to figure out the whole piece, but you'll often be able to fill out most of it. All right, so let's turn our papers and look at question number 1. Okay. And I'm going to draw the picture a little bit larger so you can see it down here. Ma'am. Sure. Mid-segment is midpoints of a triangle. And we look for the hidden parallelogram. And the other thing that we'll find is the small side is always parallel to the larger side. So for example, if we look back at our picture, this 5 is parallel to this thing, which is 10. Right there. If we have our 7, it's basically whatever line is not touching the edge of the triangle, that line is the one that's parallel. We good? Ma'am.
If this class is easy, when they get history,
Start again? I didn't hear you. It ends at 10 or 12:40 because we still have to give people time for lunch who went at 12:14. Okay, so number 1. I'm going to draw the picture larger. Thank you for respecting the people in this class and people watching the video later. NDO EMC.
Can you also do a larger example, or is it just easier to understand what I'm doing?
That way, I'm doing the larger example because you might not see what I'm writing on that little triangle. Okay. That's it. Okay, so it tells us that CD and E are midpoints. It tells us that CD equals 4. So I'm going to draw CD and put 4. It tells us that CE is 8. And it tells us that DE is 7. So right away, I can fill out what all the other pieces are. I know that because this is 4, if here's my kind of hidden parallelogram right here, this piece down here has to be 4. And because this is a midpoint, this side also has to be 4. I could also do this like other parallelogram that way. Doesn't matter. If this is 7, right here, I know that the two pieces on the side are 7. And then these are also 8. So now that I filled out my triangle, these are 8 because here's 8 here. So this is the side that it's not touching. This is the parallel side. So each of these pieces on the parallel side are 8. So now when it asks us to find MO, as in letter A, well, here's MO down here. So I know MO is just 4 plus 4. Because I know CD is 4, so I know each of these pieces are 4.
Oh, okay.
And then I add them up to get 8.
And then you have DO plus NO equals 8. How do you get that?
DO and NO, because this side right here is 8. This orange line. Yeah, parallel. Whatever line's parallel, each piece is 8. It's mostly because this is called the midpoint, midsegment midpoint. So whatever one is, the other one is also. Good questions. Okay, now I'm going to do no, which is NO, which is this line here. 8 plus 8 gives me 16. And then they want MN, which is this final line. 7 plus 7 is 14. So again, it's way easier if you draw your triangles first. And then after drawing the triangles, you go ahead and figure out what they're asking you. That is a 14, ma'am. Not that that makes it look any better. I know. AKA 14. Okay, can we go on? Let's go to number 3, because remember number 2 is not going to be like anything on your test, to my recollection. Again, I'm going to just draw this separately so that I can write larger with the markers. L, O, B. Oh, look at that, Labrat.
So did we skip?
We skipped 2 because it's not going to be like anything I believe is on your test. Okay, so now they tell us this is different. Before, they gave us the midsegments. They gave us the inside pieces. Now they're giving us the outside pieces. So because they're giving us the outside pieces, if we go from the small to the big, we multiply by 2. So if we're going from the big to the small, what are we probably going to do? Divide by 2. So here, they tell us that LB, this whole thing is 19. So how much is each one of these little pieces if the whole thing is 19? 9.5. And because, what? Because remember, this A stands for midpoint. So mid is we divide by 2.
Does that mean R to O?
Not R to O. which line is parallel to LB? This one right here, RT. Remember, it's always going to be the inside line that's not touching the outside line that you care about. So right now I care about this line right here. So the only line that's not touching the marker is this RT. 19 divided by 2 is 9.5. That's how we got that. Next we have LO, which is 35. I got it because it told me right up here. So then this whole thing is 35. So each piece, half of 35 is 17.5. So that means this is 17.5. This is 17.5. And then AT is the line that's not touching it, the inside line. So that's 17.5. The last one they gave us is OB, which is this huge one here. That's 29. So that means that each one of these is half of that, 14.5. Which, ma'am. Okay. Did you understand the other triangle? Okay. Yep. All right, so I'm gonna, if you still need the paper I did, it's right here. I'm gonna just do a real quick example down here. Okay, so just to clarify what's happening, I'll draw on this little blob. If I have a triangle and I connect the midpoints of the triangle. Do you remember before when I had the triangle, if I said that this part was 5, we knew that each of these pieces was 5. And we do 5 plus 5 and we get 10. All we're doing now is instead they're telling us, all right, this piece right here is 10. So how much is each of the pieces? 5. Well, if this whole thing is 10, each of these pieces is 5. And then we said, well, whatever side is parallel is the one that has the double the measure. So the side that's parallel to this purple line is right here. So that means if this is 5 and this is 5, this also has to be 5. So the only difference is we're just going, instead of small to big like on the first page, we're going big to small. So this whole thing is 12. Each of these little pieces is 6. And that means this also has to be 6. Better? Me? You can say no. Whoever asked, someone asked the question. Kyra, better? Ma'am.
I understand why. So, the other line that
this one?
No, the big one. Yes, that's.
Yep.
The other opposite one. Yes, but that's
not necessarily. That's whatever this value is. So if this was 10, that means each one of these would be 10 and the whole thing would be 20. It's whatever this number is. So if this number was 6, then yes, each of these would be 6 and then it would be 12. It depends on whatever the midsegment is. Good question. Anyone else? All right, so let's go back to the problem for number 3. It wanted us to find RT. Well, here's RT. We already determined that to be 9.5. Then it asked for AT. AT is 17.5. And AR is 14.5. Okay, so we did not do 4 and 5 just because they're easy. And if you understand 4 and 5, I mean, if you understand the ones that come later, you'll understand 4 and 5. Okay, and actually we stopped at, I'm going to cross out 6. Let's look at 7, and 7 will be our last problem for today. Because it's a pain in the butt. Okay. Everyone look at number 7, please. Okay. So basically, they give us variables and the perimeter. So in order to solve this, in order to solve this problem, we have to create a very long, ridiculous equation. So first of all, let's label our outside pieces. So if we know that this is n, that means that each of these pieces has to be n. Agreed?
What?
Because this is the parallel side.
Oh, okay. That makes sense.
Then if here's our 1/2 n is right here, that means this is our parallel side. So each of these is 1/2 n.
Wait a minute.
P2?
Wait a minute.
P2. Thank you.
Wait a minute.
Yep.
I'm confused now.
We're on number 7.
I'm there.
And so they gave us the inside pieces. And remember, when you give us the inside pieces, each inside piece represents the outside piece.
So where's this n right here?
Yep.
That's 7, 8. 7, 8.
This is n. This one right here is 7/8 n.
Oh, that makes sense.
So that means this is 7/8 n and this is 7/8 n. Okay, I am going to go fast on this one because I want it done before the bell. What we need to do is we need to add all of these pieces up, all these outside pieces. So I'm going to do 1/2 n plus 1/2 n, that's this side, AC, which equals n. BC equals n plus n, which equals 2n. And then AB equals 7/8 n plus 7/8 n, which is 14/8 n.
We have to solve this?
Yep. And all of that equals 32.
Put my stuff on.
Now, don't put your stuff away. You have 2 minutes just because they let out the lunch. So hold on. So here's what I recommend doing. I recommend let's combine these. That gives us 3n. The easier way to do this is to multiply each one of these pieces by 8 to eliminate the fraction. Then when you combine like terms, and I've done this problem before, and divide both sides by 38, you're left with 8. All right, pack up.
Wait, you're posting this one.
It's already posted.